All right, welcome to a lesson we've actually planned, unlike last week. This is soldering. So all of you should have gotten kits with soldering iron, a bunch of other junk, and a circuit board that John designed for us. And today we're going to be assembling that and talking about soldering and some electronics. So let's get started. So the first thing, didn't finish the slide, but it's close enough. So every design we make in CAD, so all of our flight control boards, ground station boards, data acquisition boards, all the ones we make, we have to be able to manufacture them because we can't afford to have someone else make them for us. So this is why it's really important to learn about soldering. And if we don't, then you'll end up buying a board or designing a board. You'll get it and find out that you can't actually assemble it, and it's really problematic. And you have to wait a few more months to get the next one. So hopefully we'll do some surface mount soldering later. That's what we do in all of our boards mostly, but through-hole components came before that, and they're really still quite good and useful in many cases. So that's what we'll be using. So moving on to safety for soldering, I think we gave you all safety glasses. If you have them, please wear them. I know that some of you have soldered before. I've soldered before without glasses. I've had too many close calls that I kind of just wear glasses now. So yeah, you don't want flux in your eyeball. It's not fun. So most of the rest of the safety is common sense. The iron is really hot. You can burn yourself very easily. I've done it many times.
Is that next door? I have no idea.
Is someone sending messages here that I'm missing?
What is happening?
Oh, yeah, that's okay. If you have like glasses, regular glasses, that's totally fine too. It's just something to keep like flux from going directly into your eyeball. So just be careful. You know, it's tons of people solder without glasses. It's just like try to be careful. So there's things you can do to mitigate that safety issue there. So yeah. Second thing with the soldering iron, make sure you put it back in the stand. All your soldering irons should have stands. If you put it down like randomly on a table, you can burn yourself or light things on fire. We don't want that. So please be safe. It's very hot. And then sort of the weird one is leaded solder. So in both of your kits, we gave you leaded solder, and there's also lead-free solder. So both of those solders have flux in them, and flux helps the solder flow and make nice metallically strong joints. But it also creates fumes. So it's not an issue like one or two times. It's more of a repetitive thing. So if you have a fan, if you can open a window, that's great. Do that. It'll help keep your room ventilated. And that's important. Try not to breathe them directly in. It's not very fun. You'll get a cough or whatever. Then second thing with leaded solder, the only thing with leaded, these are the 3 points with leaded solder. If you do this every single time, you'll be absolutely safe. You'll never get lead poisoning. You'll never see lead in your blood. So wash your hands immediately after soldering and avoid touching things unnecessarily, especially your face. Don't touch your face when you're soldering. It's just like, you know, wearing a mask in coronavirus. You just don't want lead in your workplace being exposed to you frequently. If you're not comfortable with that, please use the lead-free solder. It's there for a reason. It's not as easy to work with, but it's still solder. It's still going to make an electrical connection. So that's what's important. When you're done soldering, clean your workplace. Wipe it down with like a damp paper towel. Throw it right in the trash. Never eat and drink while you're soldering. That's just going to increase your chances of getting lead in your system. Before you eat, just wash your hands, clean your work surface, your keyboard, your mouse, that sort of thing. You can never really be too cautious, although it's not the end of the world if you miss something. Just again, common sense, safety, keep things clean and neat. That's essentially all that's there. Does anyone have questions about leaded solder safety, anything like that?
Just an FYI for everybody, the leaded solder is in a plastic bag that you guys all have, and then the unleaded solder is in a tube. It's like a spiral inside of a tube in your kit. There, Matt's showing it right now.
Yeah, that's the lead free. Okay, Jen and Molly, the flux fumes will diffuse pretty quickly. It's not a big deal at all. You're not going to set up smoke alarms. Just like don't, take a big breath of it. As when I did an electronics job last summer, my boss was very old school. He basically just said, take a breath, go in. That's the way. It's okay to do it for the first few times. If you're soldering a lot, definitely figure out a good ventilation system.
Yeah, that is correct, Johnny. We're only going to be doing this for a couple times, for at most a couple hours. It's not a huge deal. These are just really important practices if you're doing this over time, because that's when you get problems with lead, is if you're continuously exposed to it. But you should use the same practices whenever you're working with it.
Yeah. A good way to think about this is back when all of our parents were alive and kicking around, like, in cars and stuff, all the gasoline was leaded. So chances are our parents were exposed to a lot more lead than we'll ever be exposed to in our lifetime, simply because all of their cars, gasoline had lead in it, and was just spewing into the environment. So,
Quinn, yes, you are soldering. I mean, you can, if you want to go somewhere else where you have power to solder, that's fine. I think you probably wouldn't want to do it in like Curry, but it actually is officially, like, there's nothing wrong with it. It's in the handbook. Soldering is allowed. We've actually looked into this before. Just don't set things on fire. That's the important part. And don't. Yeah.
If you don't feel comfortable with any of these things, I'll go over the differences between the two types of solder in a moment here. But yeah, again, if you don't feel comfortable or something, there's still a lot of valuable information we'll cover, and we can help you get set up to potentially something that's easier for you to solder in. But for now, we'll continue. If you get started and it's a problem, let us know, and we'll help you figure something out for the future, so we can all get these boards made. Because the end product is going to be really cool, I think. So, all right, moving on. Yeah, so this is literally what I just said. So use common sense. Lead does not vaporize at soldering temperatures. You can't. There's no lead gas. It's only the flux. So the only way lead can enter your body during soldering is touching your face, eating, drinking, yada yada yada. Solder can splatter. If your solder is splattering, then your iron is too hot. Flux spatter is going to happen all the time. If you look at the particles when it spatters, you can tell if it's either flux or solder. So again, if your solder is splattering, lower your iron temperature. You can do that with the potentiometer on the side of your iron. I don't have one with me, but potentially someone else with a kit can show the group. Yeah.
Yep. This little thing right here, I think.
Yep. Cool. All right. So for those of you who have taken material science, this will be a review. But leaded solder is a eutectic alloy. So on their own, tin has a higher melting point. Likewise, lead has a higher melting point than their eutectic alloy, which is at the point 61.9% tin by weight. So with a eutectic alloy, it's either solid or it's liquid. It's never in between, unlike these other sort of alpha plus liquid or beta plus liquid phases of your solder. So you can get different compositions of solder if you need it to melt at different points. So lead-free solder generally consists of tin, copper, and silver, sometimes tin, antimony, bismuth. There's a bunch of other ones. I don't know if they're eutectic. They just essentially they're alloyed to lower the melting point. That's the goal of the solder. So yeah, if you have any questions, you can ask your material science teacher if you're a mechie, or ask me. I can probably find you something to read about it. All right, moving on. So good soldering technique. So you want to place your through-hole component through the board, bend the leads to hold it in place, bring the iron to the lead, and then bring the solder between the iron and the lead. And then you add a small amount of solder. as you can see in the GIF here, this guy's doing a pretty good job. Makes a nice looking solder joint. So you'll see the solder actually gets pulled into the hole. The hole is plated with metal all the way through the board. So when you see the solder get pulled through the board, you know it's all set and you can pull the iron away. So the key is to hold the iron long enough to get the solder to pull into the joint, but not too long that you start burning things. So it's sort of takes a lot of practice, but it's not too hard. You should get it hopefully pretty quickly. So moving on. So in order to like easily assemble your PCB here, which is this white board that you should have in all of your kits, you should pull it out now. We'll take a look at it in a second here. So in order to properly assemble your board, you should be familiar with the layout of the board and all of the components that are going on it. So we'll look at the schematic here in a second. So I'd recommend clearing off the space. We'll take a couple minutes, clear space off your desk, set up the board and in that bag of components that I gave you. I should turn off the background here. It's really annoying. And you can admire John's great selection of solder mask color. It's very nice. I don't know how to open this in. Oh, geez.
Who's John A? What's his last name?
John, introduce yourself.
I am John A. John Alessio.
Yeah. His name, I put his name on the schematic because he didn't do it. So if you open up the
Oh,
PDF,
it says it down there. Designed on the. Was it down in the bottom before?
I added it.
It's on the PCB, but I'm too lazy to put in the schematic.
Okay.
So yeah, I encourage you all to put your names on your schematics and stuff. It's fun, but also you can put them on your boards. Hopefully we'll do board design. I can't figure out how to turn off this stupid video background here. Oh, there are the controls. Oh, okay. More. Okay. Settings. So I'll just give you guys a few minutes to take out all those things and look at the components a little bit.
We gave you spares of a lot of the components, so.
Yeah, hopefully. If I miss something, well, yeah, you can complain later. But,
yeah. But yeah, so you should have a bunch of LEDs, which are you'll see a little like bulb with two wires coming out of it, and that's a LED, so it's like a little light. It's just one of the things. You have a bunch of those, so if you want to play with one of those, feel free, because I think you have enough. I think you have 2 or 3 of each color, because I ordered way too many. So.
All right, virtual background. There we go. Ugly mission hall apartment room. All right. So here's the board. Actually, I should just switch over to the camera soon here. Second, and then so I will pull up the schematic again here. So, oh crap. All right, so yeah, so lots of the components, or not lots of them, yeah, a lot of them are polarized. So you have to make sure you install them in the correct orientation, otherwise they won't work correctly. So that includes basically all of the integrated circuits, all of the diodes, so the LEDs, and I think the buzzer. I don't know, John. Is the buzzer polarized?
Sorry, the buzzer is technically polarized, but I think it works in either orientation.
Okay.
But there is, just in case, both the buzzer and the board is labeled.
All right, great. I'll simplify things. And then pin 1 of an integrated circuit. So the only IC on here is our microcontroller. It's generally designated by a dot on both the board and the chip. In this case, it's designated by a notch on the silk screen. So if you look at the big rectangle in the middle of the board, you will see a sort of a notch in the silk screen. So I'll show that on camera in a second here. And then moving on, this is the schematic. We'll reference this a lot while we're soldering. For now, yeah, we'll just quickly, let's see if I can do this pointer. Yeah, so this is, I'll just do a quick overview of this and then you guys can ask questions as we're soldering. We'll have plenty of time there. So essentially our power to the board comes in through our USB connector, either the USB connector or our header here. So I think you can switch between those using this jumper header. Is that correct, John?
Yeah, so you can switch in between using the VN port, which feeds to the 5-volt regulator on the board, and the USB power by using the jumper. Okay. That's like that 3-pin one that you got there.
All right, cool. That sounds good. All right. So our linear regulator takes our power greater than 5 volts and we'll bring it down to 5 volts so that our circuit can use it. Our headers are how we interface with the board. So all of our wires will connect to the headers. Our microcontroller does all of the processing. This is a regular Arduino microcontroller. It's actually the exact same microcontroller as are on your red boards if you got those for COE, Cornerstone. They're exactly the same chip. They're just in a different package. So package is basically shape or the orientation of the pins. Then in order to talk to our Arduino, we need to use a USB data to serial converter. And that's what allows us to communicate between our computer and the Arduino and program it and talk to it back and forth. So we can go over those in a bit more detail later on. But for now, I think everyone, I'm going to stop sharing and I think everyone should get their soldering irons out. Get your soldering irons out, get your solder out, get all of your components laid out, and then we'll get started. So I'm just going to set up my other camera here. We'll do that. Let me know if you have any questions.
The one that's lead free, like, do you have a preference or can we just choose?
For solder, it's going to be easier to solder with leaded solder. It melts at a lower temperature and it flows better. Yeah, the one in the baggie. Just with the leaded solder, just be extra careful to like don't touch your face and wash your hands when you're done. That is all. This one, oh, there it is.
Sorry, where can we find a schematic for the circuit?
So I sent you a PDF.
Okay, thank you.
Oh yeah, Quinn, we are making. Uh-oh. Yeah, we are making an Arduino, Quinn.
Okay, got it. Sorry.
Yeah, no worries. So Ethan doesn't. Oh crap.
I'm talking to Ethan about it
Okay.
now.
All right. Cool.
It's pretty sick.
Yeah, it's very satisfying to
Okay.
burn the woods. All right, so I'm just gonna lay out all my components. I'll send the PDF one more time, just in case you guys don't get it.
Yeah, because I think you can't go back to messages that were in the chat before you joined.
All right, there it is again. It's a PDF file. Just gonna get my. All right. So once you get your soldering iron plugged in, while we're waiting for other folks, turn it on, put it in the stand, let it heat up for a little bit, and then what you can do is, I'll show you guys on screen here. Let's figure out how to do this.
The sponge.
Oh yeah. Oh shoot, yeah. Well, I'm kind of lazy and never put water on the sponge. You can if you want.
Oh, do you just use the sponge without water?
I mean, mostly I forget. And I don't really feel like going to get water. So,
What
Okay.
temperature should we put our iron on?
all right. So my recommendation for that is to start like really low and just keep bringing it up until solder starts melting, and then give it like a little bit more.
Okay.
Maybe even a bit more than that, like because you want it. So solder melts, I think, at like 100 or 210 degrees Celsius, the regular leaded solder. And generally, my iron is at like 280 to 300 Celsius, because you need a lot of heat transfer in order to get the solder to actually melt and flow into the board. So the higher, up to an extent, the higher the temperature of the soldering iron, the better the solder will flow. So
Wait, just to be
That's
clear,
the
this is the loaded solder, right?
in the Ziploc baggie,
Oh,
I can't see.
Ziploc bag.
If we may not have given you more. We could have missed a few things. My soldering iron is
How do
already
you-
smoking.
How do you set up the stand?
Um,
Do you just
To be honest, I don't know. I haven't. I just looked inside the kit. I'm guessing you install the holder into the base.
Yeah.
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 I think you have to. I think you can do it just with your fingers, but the little bolts on the bottom, you can unscrew them and then put the pin through and then put the bolt back on.
Here, can someone show a loaded solder again?
this? I think.
Yeah.
So yeah, normally it comes on big spools like this. We figured that would be too much to give everyone. So.
Okay. Ben, I just realized that I did not give Ethan the right kit. I have one in my hand. I'm gonna run it over to him now.
Okay. Sounds
Ethan,
good.
if you heard that, I'm going over to Ivy now.
All right. I'm gonna switch my camera to my.
I think I am
Too
missing.
long.
I think I am missing a leaded solder.
All right. Just use the
Okay.
lead-free solder. That'll be fine. You just need
That's
to
a-
iron it a bit
That's a
hotter.
plus. That's a Placivio. No.
That's Liam's holding it right now. Liam, you are holding the lead-free solder.
I see it. Hold on. Ah, thank you.
What does the base for the stand look like?
This is this kind of sheet metal thing.
It's like on the far side where the multimeter
Yeah.
is.
Multimeter. Right.
Oh. Oh. Got it.
This camera may not work, so I'm gonna see if I can figure out how to turn
You
it.
can put the ground.
So did I set this up properly?
Yeah, it looks perfect.
All right, cool. And then this is the leaded solder, right?
That's the soldering iron.
Oh, this thing?
That's the leaded solder. Yes.
All right, cool.
All right. I'm gonna see. What? All right. Let me ask.
This can
Do
only go
you?
well. I have unfinished homework due at midnight.
You Dan, what are you doing? What the?
It's fine. It's fine.
Okay, I'm kidding.
Yeah, I have something due at midnight too.
Oh my god.
I probably do, but I haven't checked. So.
Okay, wait. Again, just to be clear, this is a solder right here.
That Quinn, are you asking?
Yes, yes.
Yeah.
Okay.
That is lead-free solder. Yes.
Got it. Okay. Yeah, I don't have lead solder.
Unless they
Okay.
lied to us and they sent us leaded solder. So let's treat them like the same.
Okay. And then there's a stand. Oh.
I'm getting a viable camera.
Can I see how someone put the stand up? You have a disc?
It's like a black sheet metal stand. Someone said.
The black part is like upside down underneath.
It's supposed to smell funky, right?
Yeah, it's gonna smell.
Alright.
The first time you fire up a soldering iron, there's all sorts of like, things. that are
Because I feel like
heating
my
up.
roommate's gonna wake up to the smell.
Okay.
We're not.
Okay, I found the lead solder. Never mind. I guess I
do this
opened it.
On top of a specific surface, or like the table is fine.
I'm using a silicone mat because I have one.
Mhm.
If you have something else, preferably something made of plastic.
How much space is recommended for this?
Like I'm using about 10 inches by 10 inches of space on my desk, excluding the soldering iron.
Including?
Excluding, yeah, soldering iron's off to the side. I'm going to, let's see. Can everybody see my video all right? I just can't tell how good the quality
It's
is.
good to me.
Yeah.
in
Oh,
video.
can you link the PowerPoint so I can have the instructions on how to solder up?
Yeah, that'd be a great idea
Yeah.
for the people that have not soldered.
I will send the PowerPoint. It's not very detailed. I'm gonna go through it. We'll go step by step each.
Perfect.
Most of
Yeah.
the parts. I'll probably do one of each type, and then you guys can do the rest.
I've soldered before. I've just never been taught how to solder before.
Yeah, that's how I started too. So it's all good. All right, so I guess we'll start in, let's say 2 minutes. We'll start at 8:35. Okay, it is. This buzzer is labeled. That's good. Yeah. So while people are getting things set up, I'll just show you. Here's my soldering iron. Here's my solder. So if you just want to test your soldering iron, just bring the solder to the iron, and mine's a little cool, but you should see it melt pretty easily, and should create like a small ball on the iron, and then you can just wipe it off. You should have gotten like a yellow sponge. You can just wipe off the iron on the sponge to clean it off again. You're supposed to put water on the sponge, but that's a lot of work, so I'm not doing it. You're welcome to. Yeah, but generally I hold soldering iron with my writing hand. I think someone here is ambidextrous, so have fun. And then the solder with my offhand. And then the board will just leave on the table. So while I'm waiting, I'm just going to touch some stuff up. Sorry, it's not hot.
So should we take out the board? And like, that's it?
If you have the board, yeah, you should take it out, and we'll get started in a moment here.
This is the board, right?
It should be what looks like on my screen. Yeah.
Yeah.
It's just thank you for those of you who are wearing safety glasses.
Can I even wear them?
So I'm just touching this up. You guys shouldn't. You can
I'm
try.
offended. You didn't think my solder joint was good?
No, I don't know what's happening. It's very weird. It won't fix. Like there's only like one little piece of solder, but I think it's actually soldered underneath the part instead of on the side. So, no, the rest of them look great. I don't know how you did 25 boards. I applaud you.
I didn't actually, because there's two of them I had a weird issue where I couldn't get all the solder on the FTDI chip. I couldn't unshort some pins, and then when I tried to pull off the chip, it would rip the pad off. And it happened on two boards the exact same way. It was weird. So I assembled 23, I think.
Yeah, JLC PCB is kind of their adhesions. All right, it's 8:36. I suppose we'll get started. Yell at me if you don't want me to right now, if you don't think you can catch up. All right, so when I'm assembling a board, I always put the biggest components on first because they're generally the hardest to access. They'll probably be in the middle, especially if they're ICs like this. So this long chip here is your microcontroller. It's an Atmel AT Mega 328. I forget all the specs. It's an Arduino Uno equivalent. So you'll see that on the chip, there's this notch on this side here. And you'll see on the board that there's also that same notch on the silkscreen right here. So what you want to do is just rotate the board so you can line this up easily and install the chip. You're going to have to do some bending of the pins probably. Don't worry too much about like breaking things. They're pretty sturdy.
Does orientation matter? As in like.
Yes, it absolutely matters. It will not work if you don't line up the notches. Yeah. So line up the notches. Ask me if you have a concern about how you're doing it. So it's going to be very hard to undo, especially this chip. Okay, this is harder than I thought. I use the side of my table to bend the pins inward because I can do it all at once. And so once you get those lined up, it should just slot right in. And you should see on the side that all of the pins look like that. They're all flush to the surface of the board. And you should see all of them poking out the bottom like that.
And like the name on the whatever it is, on like the pins, should it be, I guess, like readable if like from the arrow and U part? I guess like it doesn't.
Yeah. Yep. That will screw up your orientation as well. So make sure it's on the top side of the board like this, and the notch is on the same side as the notch in the silkscreen. Just like that.
We should have our soldering iron should be warmed up now, right?
Yeah, probably.
Okay.
So just check it again. I'll show you guys again how you do that. So just take your soldering iron, touch some solder to it. It should melt pretty much instantaneously. If it's not doing that, if it's not melting at all, you need to turn that dial, I think, to the right to get the soldering iron to heat up a bit more. Okay, I'll keep going unless are people still working on this one. This one's actually kind of a pain. So
Yeah, I'm still bending pins.
yeah, I use the side of my table and just like push all of the pins at once. I can also show you a second clip to show you that. So I've got the chip here, so I'll just like push it the side against the table to push those pins in, flip it over and do it the same. Just need to do like 0.5 millimeter, and that should be enough to get everything lined up.
If we have the chip in place, should we start soldering?
If you think you're confident soldering, yes. Otherwise, you can wait, and I'll show you the process.
Do you have a suggestion as to what to do if the pin breaks off?
Yeah. How can you show me?
I mean, like, yeah, it's just literally.
Break off.
I don't know if you can see it because.
Let me find your video here.
I mean,
Which pin?
So if we're on the side that's not the notch.
Yeah.
And we're looking like with Atmel upwards, then it's the third from the right, I guess.
Third from the right. So would it be, I don't know if you can see my video.
Yeah.
This pin?
Yeah, I think so.
This one?
Or maybe on the other side, like the bottom.
That one. Okay. So what we can do, all right, so pin 1 is always designated by this dot here. So we'll go and count over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's the 12th pin from the dot, is that correct?
Yep.
All right, so if you go to your schematic that I sent you, and you look at pin 12, it is designated as PD6. It's your D6 pin, so it just goes to a header. So unless you really care about that pin on that header, you don't need it. You'll be just
Okay.
fine without it.
Well, that's good then.
There are ways we can pull it out later if it's really concerning, but you can always
How flush does it have to be? Like, can there be some space in between, or do you have to push all the way down?
So there should be a little bit of space between the actual package itself, like the actual plastic, and the board.
Okay.
But the pins, you should see that the pins, where the pins get wider, those are all flush to the board.
Okay.
Yeah.
Yeah, mine was kind of tight fit, so I had to like kind of carefully get it in there.
Yeah, they can be. They're kind of a pain. I did this once already with all of your chips to program them, so I guess we have to do it again to make them fit. So, all right. So I'm going to start soldering, and we can come back to this if you have any questions.
Sorry, I just missed like the last few minutes. Could you review kind of like what we did real quick?
Oh yeah, yep. So we took our AT mega chips, which are these chips here. They look like a long like centipede, and that was a terrible analogy, but you get the point. And we bent the pins inward by taking the chip and pushing it flat against the table like this, flipping it over and doing the same to bring the pins inward enough that we can insert the chip into the slot on the board, or into all of the pins. So the key thing when you're installing the chip, make sure that this notch at the top of the chip lines up with the notch in the silk screw. I don't know if you can see that.
Okay, yeah.
Okay. Yeah, we'll come back to this, the soldering. I can answer questions while I'm soldering, but I'm just going to do just start that. So when I'm soldering ICs like this that are pretty big, I like to start with opposite corners to hold everything in place and distribute the stress in the pins. So let's say I'm going to start with this pin over here. You can start with any one of the corners. So what I'll do is I'll hold the iron to the pin, then I'll bring the solder between the pin and the iron, and then we get a pretty decent looking solder joint. So if you can see that from the side, probably not. I can turn on my microscope in a minute here. But it's sort of like a small bump right around the pin, and you should actually see when you're soldering that the solder gets pulled into the hole. It's wicked in. So you need to hold the iron there long enough that that happens.
Why do we do this?
So if you don't do that, so I'll demonstrate like a bad one on the next corner. So if I don't hold the iron long enough and I just go like this, actually my iron's hot enough that it didn't matter. Try it again. Well, I'll hold off. So if you don't hold the iron long enough, you can get sort of a cold joint, which means that the crystal structure of the metal doesn't develop correctly, and that the joint can just crack and fail, and you'll lose connection. Or B, you can get solder that doesn't make a strong joint, doesn't go all the way through the hole and make a good electrical connection. So it's just key that you hold the iron there long enough for the solder to get pulled in.
Where should we touch? I can go first.
Oh, thank you. So as long as the pins are in and they're flush, does it matter if they're bent a little bit?
No, it doesn't matter. Just all the pins should be in each of the holes. Yeah. At some level, it doesn't really matter if they're lined up perfectly either. Just as long as the notch is where the notch should be, and then all the pins are in.
Is it okay for a soldering iron to touch the pins?
Yes, they need to touch the pins. So I'll demonstrate on the next one. So the next one, you should do the opposite corner. So hold the iron on the pin for about a second, then bring the solder to the iron. And so you should touch the pin and the pad at the same time if possible. Here, I'm going to switch to my other camera here so you can see this up close.
Is it okay if like the iron touches like the gray ground part of it?
Here, let me I've got my other camera.
I mean, like the white part, like
like the board itself.
Yeah, it's called solder mask. It basically covers all the copper and keeps it. It's like not hydrophobic, but solder phobic. So the solder doesn't like sticking to it. And it's decently heat resistant, so we won't immediately destroy the board if it touches solder mask.
All
right.
Yeah,
If it's
so
pretty flush but not perfect, is that okay?
yeah, that's fine. As long as all the pins are in the holes, then that's all that really matters.
Okay.
So do you guys prefer this camera view?
Yeah, that's a really nice microscope.
Yeah,
Okay,
that's nice.
It's like
That's a lot better.
it's the cheapest microscope you can buy on the internet, so we're doing pretty well, I think. All right, so this is now the next corner. So I'm going from corner to opposite corner to neighboring corner,
Back to opposite corner.
back to opposite corner. Yeah. So then I'll do. Let's see, the pain to keep in the same place. So again, I'm holding the iron to the pin, bringing the solder between the two like that, and then bam, we have a perfect solder joint. It's hard to see at that angle. Yeah, it should look. Oh, it's all reversed. Just look at that.
Wait, I'm actually not 100% sure on what's the point of soldering though. Why do we do this?
So, let's just say you were to just insert the chip into the holes and sort of like bend the pins over, you would probably get electrical connection. It might work, but if you were to shake the board around violently or put it somewhere where it's moving a lot, those pins can shake loose, the part can come out, you can lose electrical connection, and then the board is useless, right?
Mm-hmm.
So you need to solder to make a very good, it'll make a very good electrical connection that can carry quite a bit of current, and B, it's also mechanical. It holds the part in place. So it's electrical and mechanical.
Got it.
And it's, yeah, that's why we do it. So.
Should the pin be like completely covered by solder, or is it still kind of sticking out a bit?
I normally try to keep the pin visible. Like,
okay.
I'm trying to find a good example here.
What is it? I feel like my solder is sticking to the iron more than the pin. Like,
interesting.
I don't know if that's just me being bad.
You might not be holding it on the pin long enough for the pin to heat up. So you don't want to hold it for more than like 5 seconds. So if it's not doing it in like 5 seconds, then your iron's probably too cold. So if it's not wicking the solder into the joint in less than 5 seconds, then you should increase the temperature a little bit.
Also, to be clear, it's fine if you have some solder on the iron. It actually helps the iron to heat up both the pin and the pad.
Yeah, exactly. All right, so moving to the next corner. We'll do this one.
What should be the pattern of us doing it? Doing all the corners first?
So I do all the corners first. Try to go like sort of in a strategic order. And then, you can work like middle out or down the sides. Once you get the corners, then it's pretty much free for all. So.
All right, but do you solder like just like with the board on the table?
Yeah. Sometimes it moves. So.
And then what was the thing with like the spiral thing that you set up on the black thing with the sponge that you set up like earlier?
So when you're done with the iron, you put it in the stand. So you don't want to leave it on the table because you can just like light things on fire or burn yourself or something.
Could you review how to set up the stand again?
I think you insert the spiral thing into the black base and then like tighten a nut. Can someone who has one?
Yeah, that's correct. So you take the nut off of the spiral thing, and then you put it through the base, and then you put the nut below the base. If you're looking at my video,
there are like 2 holes for it. Does it matter which one?
No, not particularly. I put the one in the furthest out one near the edge, but it shouldn't matter.
Yeah. All right, so I did 1 whole row here. You can see there's lots of flux. That's normal. But all of the pins are connected.
Wait, so the brown stuff is flux?
That's flux. Yep, you can clean that off later. It won't cause problems for us, but it can cause problems in more complex designs. So we'll talk about cleaning that at the very end, maybe next meeting.
Right now we're just trying to get the centipede thing stuck to the board with the soldering?
Yeah, so you should have installed the chip with the notch over here. Oh, no, wrong side. With the notch in the chip lined up with the notch in the silkscreen. All the pins should go through the back of the board, and then you're going to solder starting with the corners. So go one corner, then go diagonal opposite corner. I can't figure this out. Then neighboring corner, and then again diagonal opposite corner, and then just free for all to fill in the rest.
Which one was like the non-lead solder again?
The non-leaded solder is in the plastic tube with the blue cap.
Okay.
So it is fine to use a leaded solder.
Yes, it is fine. Just make sure to wash your hands. That's all I ask.
How long should we like hold the solder to like each pin?
So if you watch here, my soldering iron is temperature controlled, so it's a little bit easier. So, long enough, you should see, here, I'll try and demonstrate. The soldering iron is really good. I should use the crappy ones next time. Let me see if I can line this up. All right, so let's look at a new pin here. So if I touch, you can see it starts melting the solder on the pin. Then I just bring the solder to the thing, and then it looks like that. Right? There's solder covering the whole pad and going up the sides of the pin. That's really all you need. And it's better if it goes down into the hole. It's actually best if it does that. But these will all be very good solder joints.
So we bring the solder first to the pin?
They bring iron to the pin
Wait,
first.
iron,
Iron. Yeah, iron first, let it heat up for like a second, half a second, and then bring the solder to pin. So there's another one. There's the next one.
Is it okay if there's smoke coming out?
Yes, that's
it should be. That should be happening. Yeah.
Yeah. Try not to breathe it in.
We're essentially just trying to block these holes off with the lead, correct, or non-lead?
You can use either one, but yeah, you're essentially just trying to fill the holes with solder. That is kind of a good way to describe it. Yeah.
Oh wait, so when you begin soldering, you touch the solder to like the soldering iron to like the solder?
So again, I'll do this on this last pin. So you have the pin in the pad, right? Like this?
Yeah.
You see that? Okay, so now I take my hot iron here and I bring the iron to the pin. And then I bring the solder to the iron.
Oh, okay.
And then it should all just wick into place. Yeah. So.
Is it okay if the iron gets stuck? Like, is that normal?
That does happen occasionally. You just need to hold the iron until it comes free. Don't try to just rip it off. You'll break things.
Wait,
You might
am
want
I
to raise the
being?
temperature a little bit.
Yeah, increase the temperature.
I don't know if this is a dumb question, but the black cap of the iron, should it be on or off? It should be off, right?
It should be off.
Okay. It's just that your video has a black iron or a black soldering iron. So I was confused.
Yeah, I have a Weller iron. Yeah.
Okay, I was confused if I was supposed to leave it on.
I have a bit of brown stuff around my pins.
Yep, that's flux. That's
Okay.
normal. Yep. We'll clean it off later, or
Got it.
you can.
Okay.
Yeah. So the flux, it just helps the solder flow. It makes nice shiny metal joints.
Temperature setting, you usually put the soldering iron to?
Those ones don't have like a digital display, so I'm gonna try to describe it like.
It has like a dial though, right?
It has a dial. So you should turn the dial until the solder just starts melting when you bring the solder to it, and then increase it a bit more, so like a bit hotter than the melting point.
So if you touch your iron to the solder and it starts melting, it's a little higher than that.
So yeah, so when you touch the solder to the iron, it should melt.
The iron is the pin?
No, the iron is what you're holding with your hand.
Oh, yeah, right.
Yeah.
If you touch the solder to the iron.
So touching the solder to the iron should melt the solder instantly.
Yeah, okay.
Yeah.
I kind of soldered two together. Is that fine?
No, we don't want, that's a bad connection. So I'll demonstrate that.
right.
So let me see if I can do that here. So let's say I put like way too much solder, like I'm smoking myself out here. There we go. All right, 2 pins joined, right?
Mhm.
So in your kit, you should see something that looks like copper, like mesh, like this. It says
Yes.
solder wick on it.
Yeah.
All right, this is solder wick. So what this does is it just wicks the solder away from the joint. So if you put too much solder on your joint, or you do this, what you want to do is take your solder wick, put it between the solder and the iron, and just like hold it there until it wicks the solder up, and then bam, that's it.
That's cool.
Yeah, it's a very useful tool. Okay. I'm gonna put
to hold the wick at the actual copper. Try and hold it at the plastic spool thingy because the copper will get up quickly.
Oh yeah. If you hold it too close, you'll burn yourself.
Yeah, I've done that very many times.
Same thing with the solder. Don't hold your solder like way too close to the iron, because it'll.
If it's not working, do I turn my iron up?
Potentially, yeah.
Do they have solder suckers too? Because the cheaper wick might not work very well.
Yes,
Yeah.
they do have solder suckers.
Cool. All right, so
maybe demonstrate that as well.
I do have
Matt,
one.
do you want to hold up the solder sucker? I don't know if you
Sure.
know what that is.
I can.
Yeah.
This side?
Yep, that's it.
Thunk.
So I do have a solder sucker here. Let's do that. All right. So again, if you put too much solder on your pins, like this, like that, whatever. So let's see if I can zoom that in. Might look like something like that. You should have a solder sucker, which like I don't know if I can show this. Matt probably already showed you guys. It's got like a rubber tip. This camera's kind of terrible for this, but
Plunger thing.
So what you'll do is you'll depress the lever of the soldering iron or solder sucker, go to the joint, heat it up, press the solder sucker on, and pull and press the button, and it will just like pull all the solder away.
I have a question. So like, how are you supposed to clean the iron? Like, is that the sponge?
Yeah, the best way is to wet the sponge with water and then just wipe the iron on the sponge.
Should I clean it? Like, because there's a lot of stuff stuck on it, which is making it hard to solder right now.
Yes,
Should I clean it off?
definitely clean it if stuff is, if there's anything other than just like metal on the tip of the soldering iron, like it looks like black, like if there's just flux residue on the tip, then just like wipe it off. Re-tin the iron again with just a little bit of solder, and then you can start soldering again. So yeah. Keeping the iron.
When you're not using the soldering iron, you put it in the spiral thing on your stand?
Yeah. So again, the best way to ensure that your solder joints happen quickly is to just tin your iron. So just put a little bit of solder on the iron and leave it there. That'll help things flow when you go to do the next solder joint. Okay. I'm going to move on to the next component. It's going to be our crystal.
Yeah, how does it usually take for the solder to harden?
It should be pretty quick. If it's not like less than a half a second, then you have a problem, probably. All right, so if you look at the schematic, you'll see, I think Y1. So if you all pull up the schematic, you'll see Y1 over on the left. That's a reference crystal. It creates a signal that is at a very specific frequency. So it's oscillating a tiny, tiny piece of quartz back and forth, either a few thousand times a second or a few million times a second. I forget which one this is. And that's going to look like this silver can here. There we go. There we go, much better. It's gonna look like this. This is a crystal.
Your microscope kind of distorts the color.
Yeah, it does.
Does it come with like the little black styrofoam thingy?
Yeah, I stuck it through that, I think. It should.
Is this one, right? Like this little.
Can't see.
Let me see if I can like.
Someone has found the crystal. They can show it. It's like looks exactly like this.
Here, this thing.
This one, right?
I know the color's off, but
yeah,
it's
that's
silver.
Right. Yeah,
okay. Matt has it. Yeah, I put it through the same piece of foam that the buzzer is in. All right. So the crystal has no polarity, doesn't matter, but it goes in. It's in the schematic. It's labeled Y1, so we want to put it in the schematic area or the board area labeled Y1. So it should just slide right into place and match up nicely with the silk screen next to the area that says Y1.
And we got to solder it.
Yep. So what to do is you put it in the holes on the top, and then flip the board over and make sure it doesn't fall out. And then you should see these leads sticking up through the top. So what you want to do is hold the board down to make sure that it's in place. And then what I like to do when a component is not, let's say I lift the board up, well, the part's just going to fall right out, right? I don't want that to happen. So I want to hold it flush to the board like that, flip it over, and then push the board down so that it stays in place. Now I only have one free hand. So what I'm going to do is I'll put the board to the side for a second. I'll take my iron and I'll tin it again with a nice piece of solder like that, all right? And then I'll take my board with my other hand, push it against the table so that the crystal stays flat to the surface of the board. And then I'll just bring the tinned iron to the joint, wait for it to wick in. Doesn't have to look nice at this stage. You just want to hold it in place. So it looks terrible. I don't know if you can see, but it doesn't matter because it's holding in place. And now I can bring the solder, which has fresh flux, to the joint and do this again. And then we get a pretty nice looking solder joint apart from the solder that has climbed up the pin. So then,
okay.
Go ahead. Yeah.
Could you repeat that again?
Yeah. All right. So I've already kind of done the damage here, but so you'll take your crystal, you'll install it in the slots.
Which one's the crystal?
The crystal is the metal can with two leads. Matt's showing it. Matt has a better picture of it. Matt is showing the crystal and exactly where it goes.
Is the smoke that comes out when you solder unhealthy?
Yeah, it is. So, it's not unhealthy if you breathe it, once or twice a day here or there. It's more like weeks on end.
Wait, is the crystal in the same packet that we?
Yeah,
oh, I think I see it.
It's in the same Ziploc.
I put it in the through the piece of foam.
Yeah, I see the piece of foam now.
This is what it should look like when it's through the board.
And now, where should the crystal go through? Like
to go in the slot that says Y1. So you should see this black silk screened area.
Okay.
It says Y1.
How do you
so then,
solder without?
Yeah, I see it. I see it.
How do you solder without like inhaling like the smoke?
properly, you're supposed to do it with a fume extractor, you'll find that the university doesn't want to pay for nice things like that. So we'll use like portable fan fume extractors in the lab. When I'm soldering outside the lab, I just try to solder with an open window and a fan. I don't solder that much, so I don't worry about it. But again, if you're soldering like a few days in a row, a few weeks on end, that's when it actually becomes a problem.
What was your technique to make sure that when you solder, it's actually flush?
Yeah, so what you want to do, I mean, I kind of screwed it up here, I guess, but it doesn't really matter. So what I do is I install the crystal through the top. Then I'm going to hold it down with my finger and flip the board over. And then I'm going to push the board down to hold the crystal in place.
Okay.
All right, so just practice doing that. And once you've done that, you can slide the board to the side for a second. Take your iron, tin the iron, so you have a little ball of solder, just clinging to the soldering iron tip, just like this. And then bring your board back, hold it flush, hold it down to the table, and then bring the iron with the solder ball to the joint. And you'll see that enough solder gets wicked in there to hold the crystal in place. Then you can come back and take your soldering iron, and you can come back to that joint with fresh solder and clean it up. So we want to clean it up, plenty of solder and plenty of flux. So the solder has lots of flux. All right, cool. All right, so that was actually a pretty terrible of a joint. So again, I'll just hold it until the solder looks in. Again, I have too much solder there.
What if you get solder on like the C9 or R6?
As long as they don't fall off, and as long as they're not connecting between two components, it should be fine.
Okay.
So again, this joint has too much solder on it, so I'll just use the solder wick to clean it up. Okay, so once you've soldered those leads, or the crystal, you'll see these pins sticking up. Each of your kits should come with cutters like this, side cutters. So what you'll do is just take the side cutters and hold them, don't put them flush to the surface, hold them just above the solder joint and cut. So then when you cut them, it should leave just, like a bit of solder sticking out. I mean, these are pretty ugly, so I'm gonna clean these up.
Sorry, installing the crystal, does side matter?
No, it doesn't. It's not polarized yet.
Also, is it fine? Is it if it's like uneven?
Yeah, I mean, as long as if it's already soldered in, yeah, it doesn't really matter. You should be fine. So, mine's not perfectly flush. I don't know if you can see, but point is, it's in there, it's soldered, and the leads have been cut off. So, actually going to clean it out a bit more. This is going to be an ugly solder joint, just because of the size of the holes here. Oh, that looks a little better.
Oh, what do we cut the things with again?
You should have some side cutters in your kit. If anyone has found those and like to show.
Yes, they look like a pair of pliers. They have blue handles. Yeah, eventually someone will show them, I bet. Yep, Liam is showing them. There we go.
Pliers. Okay, I think I should find. Oh, I found them. Okay, thanks.
Okay, thanks, Liam.
Okay, so in my infinite wisdom, I've installed it. I've soldered both of the holes. I realized that there's about a fingernail's length between the crystal and the base of the board, so it's just not flush. Is that going to be a problem?
That's totally fine. Yeah, don't worry about it.
Okay.
That is the good part about through-hole components.
Yeah, things will look ugly and they'll still work. And that's even the case with a lot of surface mount stuff. It only becomes a problem when you're doing like high speed, like things. So again, I'll just show those joints, what they look like. It's kind of messy, but you know, they actually look pretty good. So I will move on.
Can you show the side profile again for height reference and cutting?
Yeah. Again, it's not critical. But you know, the better you can get it, the better it'll look. That's essentially it.
I'm right at the board when I'm trying to solder the crystal. The solder kind of balls up, so I can't tell if it's like going into the hole.
Yeah, so the hole that the crystal goes through are a little bit undersized. So as long as the solder connects between the circular pad, can't focus this, as long as the solder connects between the circular pad that the crystal is in and the pin of the crystal, you're all fine. You're all set. Yeah.
Wait, could you show which one was the crystal again?
The crystal is this metal can labeled Y1 on the skim or on the board. Yep.
I grabbed our spare kit, so now I can. I can show things too now.
So I'm going to move on. We'll have more time later to work on this and come back. Plenty of time to fix issues along the line.
Is it fine if my crystal is not all the way down? Like
totally fine. Yeah, okay. Totally fine.
Okay.
All right. So the next thing are the crystal load capacitors. These I've labeled 22P. I think I've labeled everyone's capacitors. So you'll see it says 22P on the cardboard. There should be 2 of them. They're sort of yellow things with 2 leads. And if you, let's say, have really good eyesight, you should actually be able to read the text on the capacitor, and it says that 22.
22J, but close enough.
Well, 22J means it has a reactive impedance of 22 ohms. Maybe not. I don't know. J is normally what that would be, but you know, actually, yeah, that's right. So on old capacitors, they'll label the capacitor with its impedance. So you'll learn in circuits that a capacitor is also just an impedance, like a resistor is an impedance. And so it has an unreal impedance described by the imaginary number I, or used in electronics as J.
So if you ever wondered what the use of learning imaginary numbers in high school was, you have now found the solution.
Yeah. And they're actually very useful and kind of fun. So that's subjective, but whatever. Moving on. All right, so those crystals or those capacitors are C1 and C2, and they go right next to the crystal.
So 22P goes into C1 and C2?
Yep, so 22 picofarads is what the P means. Yep.
Okay.
So those are going to go into C1 and C2. So what I'm going to do, I'm just going to insert both capacitors into the back, and then we can slide them all the way down as far as we can. Don't worry about bending the pins or whatever. And then what I should have done with the crystal that I'm totally remembering now is once you have the capacitors through the board, bend the leads to the side, and this will hold the capacitor in place, and you don't have to like do weird things with the soldering iron. You can bend them all the way to the side, no problems.
Can you show what it looks like when you bent them all the way?
Yeah.
Also, it doesn't matter what these are unpolarized.
These are unpolarized. Yep.
For C1 and C2.
C1 and C2. So I've just don't look that great, but they are in the right place, and that's what matters. So,
Can you show it again? Sorry, I missed it.
I'm just cleaning it up one more time here. Again. Okay. Yeah, working on it. Here we go. So they look like this when they're in place. These are the 22 picofarad capacitors, 22P. These go in C1 and C2. So I'll install them and then flip them over and bend the leads to the side like this, right?
How far in should we push the C1 and the capacitors on?
As far as you can. Yeah. Don't push them so far that you start like cracking the yellow casing. But yeah, they should be like, a couple millimeters above the surface like this.
Does it matter if the leads are touching anything?
They should be, when they're bent over to the side, no, it doesn't matter. We're going to cut them off.
Okay.
How do you clean the tip of your soldering iron?
Yeah, so you should have like a yellow sponge. If you have some water, I suggest you add some water to that sponge. Then you can wipe your iron on that.
Okay. Can you show the other side of the capacitor where you made it diagonal or something to like secure it in place?
Yeah, this is the side, so you can see I've bent the pins to the side.
Okay.
So it goes through, it's gone through, and then I've bent the pins to the side like this. And so the capacitor should line up with the silk string, as you can see here. They should be perpendicular to the crystal. C1 and C2. All right.
And there's no polarity on them too?
Nope, they're unpolarized capacitors. So once I've done that, bent the pins out to the side, I'm going to take my soldering iron and solder. I'm just going to bring, again, tip to the pin, solder to the tip. And just let it melt in like that, and then pull away. Same with the next one. Well, let me bring this into view. And so tip to the pin, solder to the tip. Let it wick into the hole, and there we go. Flip it around so I can access it with my writing hand. Again, just the same way. And so you only want solder right where the capacitors come through the board. So after it's soldered, it should look like this. Okay, and then you'll take your side cutters again, your cutters like this, and just I normally try to leave a bit of the solder blob above the surface, so I'll just cut like there. Same thing here. Leave a bit of the solder blob above the surface. Do it again, and then two more on the other side.
Another thing to note, when you're cutting these pins, I don't know if Ben said it earlier, be careful because they do like kind of shoot off everywhere.
Yeah, that's also why we wear safety glasses.
It's another, yeah.
Could you show what the capacitors look like again?
Yep. Look like this. They say 22J on them. They should be in the cardboard thing that says 22P. Yeah, that's got a good zoom in there.
I don't think I pushed mine in as close to the board as you did.
Yeah, it doesn't matter.
Yep, those are fine.
Yeah.
Cool.
So I mean, all right. So you can see the difference between my solder joints if you're curious. So like, if you look at this one, all right. So you look at this one here. You can see how the solder has not been pulled all the way up to the surface, and this one it has. So this one is a good solder joint. This one is mediocre. So what I'm going to do, I'm just going to flip it back over to the other side.
You don't understand.
I'm just going to reheat that joint.
No, but like when you say, what are you working on? It's not what are you working on. It's just so many different things.
Adding a bit more solder, let it wick in. There we go. That's good. Nope, that's right.
I don't know. It might just be me, but my unleaded solder is not wicking through, like up through the board, like yours did.
Yeah, that doesn't surprise me.
Yeah.
Oh, so another thing when you're soldering these capacitors and everything else, be careful not to lean your soldering iron on this chip. If you melt that chip, your board may not work right. So just be careful and sort of keep track of where all of your soldering is. Okay.
I had the worst teacher. I'm convinced that the worst.
So I'm going to move on. Again, we'll continue this next meeting. We can ask lots of questions and stuff. But the next thing I want to do is probably going to be this button. So you see here it says S1. It's a momentary switch. Same word for a button. I should have given you guys all 2 buttons or so, I think.
Did you cut the the leads off the capacitors or no? Yeah.
Yes, I did.
Oh, you did.
Yeah.
Where is it? Okay. What does the
So-
tool look like?
It's side
Oh, I
cutters.
see.
So yeah, cut the leads off the capacitors and the crystal. Nothing else.
And the crystal.
Oh, you cut it for the crystal as well?
Yeah, I cut the leads on the crystal as well. Anything that's sticking out like more than a millimeter, you should cut the leads. So
Okay.
like the Arduino chip is totally fine. You don't have to bother with that. But everything else, I cut the leads so far.
My capacitors at like the top are a little bit like sideways.
Second?
Like the capacitors, like the orange parts at the top, they're like not as straight.
Yeah, that's no big deal. Yeah, they'll work the same.
Just like tilted a little bit.
Yep, that's totally fine.
Would you repeat which spots the capacitors go into again?
Second?
Which spots the capacitors go into?
So they should be labeled 22P. They go into C1 and C2.
Okay. Thank you.
All right. So the next thing
There
is the
will
button.
be like two different ones that have that same like yellow package, but they shouldn't be confused or else it might not work properly.
Yeah. All right. So the
Is
next
it the
one is
end of the world if the solder doesn't come all the way through to the other side?
yeah, it's totally fine. Yeah.
Probably just good solder technique if it does.
Yeah, yeah. Like when I did soldering basically as a job, my boss would tell me that it had to, and it's good because ours were going underwater, but this is not going underwater, so don't worry about it. All right, so the next one's the button. It's over here. It looks like this. I've installed it in S1. Doesn't matter how it's oriented as long as all of the pins go in correctly.
Sorry, what did you install?
The button, the S1. It looks like a button, like this.
Oh, not the big one, not the big button. Okay.
There's only one button.
Oh, my bad. And this one's not polarized or anything?
Nope, just it's kind of it's rectangular, sort of, and if you include the leads, so the leads look like this, and that's going to install this way. So I'm just going to lean it over.
That S1? Yeah.
S1, yep.
Right above R5.
Exactly.
And we'll solder this one too.
Yep, so I'm just going to, again, flip it over. It kind of holds itself in place, so I'm not going to worry about holding it down. You see all 4 pins should come through. I'm just going to solder those.
How many more components are we doing tonight?
I mean, I'm probably going to go like 5 more minutes. Yeah, I need some water. We'll come back to this. I think I'm going to wash my hands first, then get some water, then I'll hang around for some questions, and we'll move to continuing this probably next week.
What component are we putting in?
We're putting in S1.
Oh.
It's the switch. It's the button.
The like big circle one?
It looks like this.
It's pretty small. It's got 4 pins coming out of it.
Oh, okay.
Yeah. Again, I don't like my solder joint, so I'm just going to touch them.
Was it the one stuck to the black foil thing?
Oh, that's the buzzer. If you're looking at this one, this thing,
yeah,
that's the buzzer.
Okay.
So we'll come back to that.
Oh, I see. I see it.
Yeah, you should have a couple of the buttons.
The button's
I
like
gave
the
everyone a
square, a circle on a square, right?
Yep.
Yep.
Okay. And where does that go to?
S1. Over in the corner of the board, sort of.
Oh, so like in between like the crystal and the other.
Yep.
long
John,
thing.
do you want to send the PDF of the silk screen? Or the board
Of
layout?
this. Yeah, sure.
That might be helpful.
It's looking fucking nice.
Does orientation matter for this button or no?
So as long as it's sort of going in, it should really only fit one way, but you can flip it around 180 degrees.
Okay.
Okay. All right. We'll do one more because we can. We'll just do the buzzer we should do last. Actually, that's a good place to stop. Let's stop here. I'm gonna go get some water, washing my hands first, and then I can answer questions. If you don't have any questions, I don't know, Tyler. What do you think?
Yeah, so I'll let
Be right
Ben
back.
go get water, and I can also answer questions. But yeah, so if you feel like you've got everything done, you don't have any questions, you're free to leave. We'll be sticking around for a while. Just answer questions, any thoughts you have about this, anything you want to talk about. Pretty open,
So,
but we'll be around till 10.
It's like, how bad is it right? How, in the grand scheme of things, how bad is it to inhale these fumes? Because I feel like I haven't failed them at least like 5 times tonight.
I think as we've been trying to say, it's not a huge deal. So like the issue becomes when you do it repeatedly. So you really have to be concerned if you're like doing this for a job or doing it every day.
Okay.
When you're doing it, like we're gonna do this 2 or 3 times over the course of like a month. It's not a huge deal. I mean, obviously try to avoid it, but it's not going to cause any harm unless like if someone has like a breathing condition, maybe we should look into something, and you can send me a message and we'll try to get some stuff together. We should get like I'm gonna work on. I was gonna give everybody a soldering fan, but that ended up being a little bit too expensive to try and work through. So best case is to open a window and get a fan like blowing across your desk.
Yeah, my brother has like this little thing, and I just like set it up so it's pointing away from me, and it just like disperses the other direction.
Yeah, I have this here that I've been trying to use.
Oh, that's like that's literally all you. That's the extent of what you'd really need. Is just get some airflow so it's not lingering in the area, because it disperses really quickly and it's not extremely dangerous. I'd never actually seen one of those before. I mean, that's kind of cool.
Yeah, it's not like super powerful, but it's like nice. It just sits in front of me.
Yeah.
Like,
I always just like take one of my. I just take like a fan, like I have just like a desk fan, and I set it up on the corner of my desk. Or I usually solder on a second table, so I have like a side table. That's usually where I do my soldering. Oh, which I actually haven't done any this year. I haven't soldered in a very long time.
Yeah, maybe you should go out there.
So
last year I grew
it's not gnarly background noise right now.
Yeah, so John just sent the layout, so that is all the different things you've been soldering, but you just have like a little PDF if you want to pull it up on your computer as well.
Am I screwed if I put the cap on too early for the soldering iron?
I don't know.
I think it's a plastic cap, but it should be fine. You might melt it a little bit, but
like it's not gonna like fuse on it, right? It's
yeah. No, you can rip it off.
Yeah.
Okay.
You'll destroy the cap before you destroy the soldering iron.
What's up, Jen? Too
That's
much
good to know.
distressed.
I don't have a fan. Should I get a fan?
If you want to, again, like
Oh no, yeah, I would.
it's not going to be a problem if you're just going to do it like these few times that we do it. If you're doing it every week, then yeah, I'd invest in the proper equipment.
Normally our soldering's done in the lab. We have nicer soldering irons, and I think we have fans. We actually use the fans less than we should.
Yeah.
But we have, so when we're doing this for large productions, large scale, and we're doing a bunch of soldering, we use the proper equipment. So.
Yeah, guess on the right side is we get our own soldering irons now. It's pretty cool.
Yeah,
that is. I see what you're trying to.
Oh yeah, we're going to. Oh, we were talking about soldering irons. Okay.
Yeah, no. I'm pretty happy we were able to do that. If I know we have very few mechanical engineers in this group, but it's all paid for from the Mechie department. Our club advisor offered to pay for it, so that's Andrew Goldstone. If you ever see him, say thank you.
That's awesome.
Yep.
Yeah.
Pretty baller.
We had a meeting with him over the summer, and we were like, "Oh, so we're increasing the scope of intro a bunch, and it's going to cost a lot." And he's like, "How much do you need?"
So, you said like wet paper towel was fine to clean up, right?
Yep. Yeah, that's good. So, all right. So what I'm going to say, you're welcome. I'd say send me a picture of your board if you're concerned or if you have any questions. just shoot me a picture on Discord, or maybe I'll make like a folder on Drive, and you all can upload pictures. We can do that this week.
There may be some people who don't have Drive access. If you don't have access to the Aerospace and You folder on the Drive, send me a message.
So yeah, you can send me a photo, and I'll let you know what parts of it we can fix up, or maybe we'll wait. Let's wait until next week when we finish soldering, and we can take a look at everyone's board and see if there are any problems before we connect power to them. That's the big one. So
for one of my pins, I cut it a little bit way too close to the board itself. Is that fine?
Yeah, just hold it up to your camera.
I'll
see if I can.
I don't know. I don't know if I could.
Oh yeah, yeah, it looks fine to me.
Who's talking?
Can you hold it flat instead of
like this?
Yeah.
It's like, I don't know. It's like, wait, hang on, which one is it? Yeah, it's like the one bottom right.
Oh, you can actually probably cut the other ones a little shorter.
Oh, really?
Yeah.
Yeah, so you see, like, if you look at mine, you'll see that there's really nothing going off to the side, sort of. It's just like, like a blob.
Okay.
So yeah.
If I got like solder over a part of the board I didn't want it to go, how do I like clean that up?
So it depends where it is. Is it on the white part, or is it on
the white part? Yeah.
So what you can do, if it's on the white part, is just take your soldering iron and just like heat it up and wipe it away.
Oh, okay.
Yeah. Or you can use the wick, which I think Ben showed earlier, and then there's also the solder sucker, which is just like a little vacuum that cleans it.
Yeah. So you shouldn't need, if it's on just the solder mask, the white part. This is like hydrophobic to solder. It repels solder. So you can just you don't normally heat it up and just wipe it away. But otherwise, if it's sticking to something else, if it's sticking to a via. A via is one of these very, very tiny holes in the board that carry signals from one layer to the other layer. If it's a via, then you might need like the solder wick to pull it away, but otherwise you should be fine.
Yeah. Right. I think that lesson 1 of soldering went fairly well.
I agree.
People asked a lot of great questions.
Yeah, definitely. Questions are the most important, so keep throwing us questions.
Yeah, and if you don't feel like, oh, I'm going to stop recording now, because you don't